Good morning, ma'am. I'm Hemant Kumar from Triple Department, A section. Now I'm going to discuss about root locus first method problem from the control systems. Introduction to root locus method. This presentation introduces the root locus method, a vital tool for analyzing control systems. Will explore how system poles shift with gain variations, which has significant implications for system stability and response. Understanding this method equips engineers with the ability to design and optimize control systems effectively. The root locus method provides a graphical representation of how the poles of a system's closed loop transfer function change as a parameter. Usually, the gain k is varied. This enables engineers to predict system stability and performance. We will cover basic concepts, construction rules, and practical applications. Basic concepts and definitions. System poles and zeros. Poles, roots of the characteristic equation, determine system stability. Zeros, values of S that make the transfer function zero, affect system response. Root locus definition. Graphical representation showing how the closed loop poles move in the complex plane as the gain k varies from 0 to infinity. Gain factor, a variable parameter that scales the open loop transfer function. Its variation influences the position of closed loop poles. In control systems, poles and zeros are critical parameters. Poles are the roots of system's characteristic equation, and zeros are the values that make a transfer function zero to the root locus method visualizes how poles move with changes in factor k. Components of the root locus construction. Root locus rules. These rules help in sketching the root locus plot. Key rules include identifying real axis segments, asymptotes, and breakaway points. Real axis segments. The root locus exists on real axis segments to the left of an odd number of poles and zeros. Asymptotes. Asymptotes are lines that the root locus approaches as it extends to infinity. Their angles are given by when n is the number of poles and m is the number of zeros. Breakaway and breaking points. Breakaway points are where the root locus branches of the real axis. Breaking points are where it returns. Criterion. These points are found by solving for where the derivative of the gain k with respect to s equals 0. Example, systems with multiple poles on the axis exhibit breakaway points, while systems with zeros measure breaking points. Breakaway points signify critical regions on these points where the system poles either leaves or an axis. Determining departure and arrival angles. Angles at which the root locus leaves departure or approaches arrival complex conjugate poles or zeros. Importance. Predict the system response characteristics such as stability and damping ratio. Departure and arrival angles indicate how the root locus interacts with complex conjugate poles and zeros. The formula involves summing angles from zeros, providing insights into system stability and response. Solving a sample problem. This is the defined transfer function. We can observe in the given identify poles and zeros. Apply root locus rules in the third category. If we apply the root locus method to g of s and h of s is equal to the given formula, the poles are at s is equal to 0, minus 4, minus 6. By applying the rules, we construct the root locus plot and identifying key features like breakaway points. Applications of root locus method. System stability. Analyze stability based on pole locations. Gain margin. Determine gain margin for stable operation. Proportional control. Design controllers to meet performance specs. The root locus method is widely used in control system design. For example, in a motor speed control system, the method helps optimization parameters for stable and responsive performance. Let me give conclusion and key takeaways. Method importance. Root locus method is vital for control system analysis and design. Key analysis steps. Define transfer function. Identify poles and zeros. Apply root locus rules. In conclusion, the root locus method is an essential tool for control system engineers. By understanding its basic concepts, construction rules, applications, we can finally effectively analyze and design stable in high end of control systems. Thank you, ma'am, for giving this opportunity. Thank you.